Hello kids, let's revise mechanical properties of fluids today.
Okay, sir.
Sir, can we ask our doubts?
Ria, of course you can, but first, we will revise some basic concepts.
Sure, sir.
Okay everyone, can you answer? What are fluids?
Sir, anything that flows is a fluid.
John, don't be hasty. Always answer a question in detail. Ria, can you give it a try?
A fluid has no definite shape of its own. Both gases and liquids take the shape of their container. They provide almost negligible shear resistance to any force that try to change their shape. In other words, gases and liquids can flow. Hence, they are called fluids.
Sir, she said the same thing in more words.
Yes, but she did add one point about fluids having almost no shear resistance, and she expressed her knowledge a little better. In theory papers, always try to write all related points in the answer. Kids, the next question is, what is pressure?
Sir, pressure is the impact of a force on a surface area. It is defined as magnitude of normal force per unit area of the surface. Pressure is a scalar quantity. Its SI unit is Newton.
That's nice. Now, John, would you like to add something?
Sir, pressure can be applied by solids, liquids as well as gases, when those are in contact with each other. The pressure due to atmosphere on Earth's surface is 1 atmosphere or 1.01 times 10 to the 5 Pascal. In fluids, pressure increases with depth.
Very good, absolutely correct. Let's move to next question. What is Pascal's law?
According to Pascal's law, for a liquid in equilibrium the pressure is same at all points in a horizontal plane. Suppose the pressure were not equal in different parts of the fluid, then there would be a flow as the fluid will have some net force acting on it. Hence in the absence of flow the pressure in the fluid must be same everywhere in a horizontal plane.
Nicely explained. Ria, do you want to add something to this answer?
If external pressure is applied on any part of a fluid contained in a vessel, it is transmitted undiminished and equally in all directions. This is another form of the Pascal's law and it has many applications in daily life.
Can you name a few such applications?
Yes, sir. A number of devices, such as hydraulic lift and hydraulic brakes, are based on the Pascal's law.
Amazingly done, kids. So proud of you. Our next question is, what is variation of pressure inside a liquid?
So simple, sir. If height between 2 points in a static fluid is h, the pressure difference between them is rho gh. So, if PA is pressure at A, PB is pressure at B, and B is h depth below A, then PB is equal to PA plus rho g.
Sir, can we say that? If point A is at the surface of a liquid, open to atmosphere, then at point B, h height below the surface, the pressure will be P, atm.
Yes, Ria, both of you are correct. Pressure increases with depth in liquid very rapidly. Although P, atm, remains almost same for small variation of height. But, if you visit a hill station, the P, atm, will change by a significant value.
Sir, can you please explain the difference between gauge pressure and absolute pressure?
Of course, dear, the gauge pressure at a point is the excess pressure at that point as compared to atmospheric pressure. Remember, we said that at a depth of h in a liquid the pressure is P, atm, plus rho gh. Here the gauge pressure is only rho gh, while the absolute pressure is the complete value of pressure, that is, P, atm, plus rho gh.
Sir, what if at a point, the pressure is less than P, atm? Can the gauge pressure be negative at a point?
Yes, dear, the gauge pressure at a point can be negative as well, if the pressure is less than P, atm. Now, John, do you have any questions?
Sir, can you explain Archimedes' principle?
Well, before I answer, let's see if Ria can tell us about Archimedes' principle.
When a body is wholly or partially immersed in a fluid at rest, the fluid exerts pressure on the surface of the body. The pressure is greater on lower surfaces than that on the upper one, as pressure increases with depth. The sum of all these pressure forces on the submerged body is called buoyant force or upthrust. The value of upthrust force is equal to the weight of fluid displaced by the body.
Okay, so that means the value of buoyant force is FB equals rho, liquid, Vg. Here, rho is density of fluid, g is acceleration of gravity, and v is volume of...
Yes, very good. Remember that buoyant force depends on density of fluid, but volume of object inside the fluid. If density of solid is higher, then the object will sink. Otherwise it will float. Next question, what is relative density of a material?
Sir, relative density is defined as density of a material divided by density of water. RD equals rho, material.
Ria, can you explain this by an example?
Sir, I can explain this using a simple example. The density of mercury is 13,600 kilograms per cubic meter. Based on this data, we can say that relative density of mercury is 13.6, as it is 13.6 times.
Absolutely correct. If a liquid has relative density of 3, it means its density is 3 times that of water. Means, its density is 3,000 kilograms per. Okay kids, tell me how many different units of pressure have you heard about yet?
Sir, I know the value of 1 Pascal equals 1 Newton per square meter, 1 atm equals 1.01 times 10 to the 5.
Sir, I know a few more. 1 torr equals 1 millimeter of mercury equals 133 Pascal, 1 bar equals 10 to the power of 5 Pascal.
Very good, so proud of you. Pascal is the SI unit, 1 atm can be expressed as height of any liquid mercury, water, wine etc. 1 bar is very close to 1 atm. And torr is pressure due to just 1 millimeter of mercury. Kids, make sure you remember all of these. I think that's enough about static fluids for now. Don't forget to make notes that you can revise later on. Watching a video is only worth your time if you write things down. Take care, and goodbye for now.